Hi guys, in this lecture video, I'll be going over the differences between the two words precision and accuracy, and we'll go over how to quantitatively describe precision and accuracy as well. So first, accuracy and precision have very different meaning to them, and a lot of time we actually mix them up when we use these two words right here in our daily conversation. And so let's now define them to make sure that we are clear of their definition. So accuracy, by definition, is how closely the measured value agree with the actual value. So there is an actual value, and now how do our data or the value that we measure agree or come close to this actual value right here? And the closer our measured value to the actual value, then the more accuracy that we would have. Versus precision refer to how closely the measured result agree with one another. So when we collect multiple set of data from different trials, how closely do they come with each other? The closer the data from different trials agree with one another, then the more precise the data will be. Now, it's very important that we learn about accuracy and precisions, and we're able to apply that in science, because whenever we make measurement in science, our measurement need to be as precise and as accurate as much as we possibly can. So now let's go over a few examples so we know how to use the terms accuracy and precision correctly. So let's say here is an example of us playing a game, throwing darts on this target right here. And here, someone played the game and obtained this result right here. How would we describe this person's result? So in this case right here, you can see that this is the bullseye right here. And when we throw darts on the target, that's where we're aiming at, right? So imagine the center, that is the target, or that where the actual value would be that we want to aim at. And now, this person obtained the following data point. So how will we describe this result? Now, I think let's now focus on the word precision first. Do you think this would we use the word precision to describe this set of result right here? And clearly, the answer is no. And the reason why that all of these data points are very far together, right? Very far apart from each other. So therefore, this is imprecise. How about accuracy? Would you describe this person right here as accurate or inaccurate? And you actually would be surprised. This result right here is considered to be accurate. Now, why accurate? Here is the explanation why. When we look at this set of data right here, we can see that these results vary all around this target right here. So you can see that these two data points right here, because they almost seem to be on the opposite end of each other, they kind of cancel each other out and end up being the average in the middle. And these two data points right here seem to also be almost opposite to each other as well. So they are averaged out to be at this where right here and this two data point. So basically, in average, when we take the average of all of this point, they come very close to the middle or the target. And this is why that this result would then be considered to be accurate, because on average it comes very close to the target. Okay, and now moving on to this set of result right here, how will we describe this person result? Then we can see that in this case right here, this person right here would be data would be precise, right? Because all of the result come very close together. However, the average of this would be in the middle, and on average it missed that target right there. So therefore, in this case right here, inaccurate. So inaccurate but precise. Inaccurate. And now, if we were to have this result right here, this would then be both accurate and precise. And these are the kind of measurement value or the kind of data that we aim at and we want to work towards in science, that we want our data to be accurate and precise as much as we possibly can. Now, how do we then quantitatively describe precision and accuracy. And this is basically referred to a set of experimental data. So when we perform experiment and collect a set of data, we can then further describe our precision and our accuracy by doing the following. First, precision is described by the standard deviation. So when we have a set of data, we need to now calculate what is the standard deviation. And the smaller the standard deviation is abbreviated as STDEV, and it also symbolized by this sigma sign right here. So the smaller the standard deviation, means that it do not come far away from where we aim at. So therefore, it would then be more precise. And the equation how to calculate the standard deviation is listed down here. Okay, so the smaller the standard deviation, the more precise the set of data would be. And now let's move on to accuracy. So accuracy is quantitatively described by calculating the percent error. And the equation for calculating the percent error is as follows: the actual value minus the experimental value divided by the actual value multiplied 100. And the smaller the percent error, then the more accurate. So the more accuracy the set of data would be. So these are basically how we can quantitatively describe precision and accuracy. And now let's try this problem right here. So a student weighed an object several times and got the following results: 4.5 gram in on the first trial, and on the second trial 5.4 gram, and on the third trial 2.9 gram. So, and now if the actual mass of the object is 4.4 gram, then how will you describe this student result right here? Would it be accurate or precise? Then now let's do some calculation. So first, figure out what the average would be. So from this three set of data point right here, the average would then equal to 4.27 gram. And also calculate the standard deviation. Now this is, hopefully you have learned how to do this from your math class already, but you can apply this equation. So in this case right here, I'll just give you the standard deviation. And we will learn how to calculate this in more detail in one of the lab. And now the standard deviation in this case right here equal to 1.26 gram. And when we calculate the percent error by applying this equation from above, then the percent error equal to 2.95%. And again, in one of the labs later, we'll learn how to calculate the percent error and follow this equation. So in this case right here, we will then see that this data right here, it has a very small percent error, right? So 2.9% error, that is considered to be small right here. And the standard deviation of 1.26, this is actually a low standard deviation right here, because the average is 4.27. And now it can deviate by this much right here, 1.26, meaning there is a big variation among our data point. And if we were to now look at our set of data, we can see that we obtain 2.9 and 5.4. They almost half this value, almost twice as much of this value, right? So there is a good amount of deviation among the data point. So therefore, it would not be precise, right? And in this case, the actual value is 4.27, and the average of this three data point come quite close to it. So therefore, we will then see we can describe this as accurate, but not precise or imprecise.